All right, बच्चों, I have received your responses. Actually, Zainab has responded. Ariba to Anushe. What's your status, beta? I'm sharing the MS with you, the marking scheme. Okay. Okay, beta. So yes, you both are right. Diamond and graphite. In part B, the structure is made up of network of bonds. Yes, actually, it is a joint lattice. It means a big network. So that is why we will use this thing that the structure is made up of a network of bonds, and or you can say structure where all the atoms are linked together and all the bonds share a pair of electrons. So here we have to give a reflection of a very big giant network. That is why it is difficult to break, and this is the actual meaning of term giant covalent structure. Okay. So in C, diamond is very hard, so it is used for cutting or making holes. Yes, यही बताया है आपने बच्चों ने. Diamond is very hard. Diamond is too hard. It's fine. Okay, actually they were not asking you in part B के what are the benefits of having giant covalent structure. They were actually wanted to inquire what is meant by. So the meant, what is the meaning? The meaning is a very big giant network of bonds. Okay, let me check the answer of Anuche. Bonds, bonds. I hope I have uh, inculcated the concept of giant covalent structure properly. Okay, बच्चों. Moving forward, आगे बढ़ते हैं नए टॉपिक की तरफ. उस पढ़ने से पहले the third giant covalent structure, which is similar to diamond, which is similar to diamond in a sense. The geometry of SiO2, silicon dioxide, is also tetrahedral. That is why I said that it is similar to diamond, the structure. The physical property of silicon dioxide include high melting point. It is hard as well and a poor conductor of electricity. In these three giant covalent structures, only graphite is a good conductor. But here there is a information regarding the structure that describe the structure of silicon dioxide and explain in terms of bonding why it has high melting point. In case of carbon, we had only carbon atoms. So one carbon atom was bonding with other four carbon atoms. But here silicon is with oxygen. Okay. So the scenario will be different. It is a giant covalent structure. Okay. But each oxygen atom is linked with two silicon atoms. Okay. And each silicon atom is attached to the four other atoms of oxygen. It has a high melting point because it has a large network of covalent bond. We know that just because of that large giant network, the melting point is high. But the thing to remember that each oxygen atom is bonded to two silicon atoms, and each silicon atom is bonded to other four other atoms. Let me show you the structure. Give me a minute so that it will be clear that how oxygen each oxygen atom is bonding to silicon and so on. All right, I'm sharing the new tab with the diagram. Here you can see, is it visible to all of you? Okay, so here you can see the statement which you just read, that each silicon atom is bonded with four other oxygen atom. The example is here, and sorry, I have changed the tab. And yes, and you can see that each oxygen atom is bonding with two silicon atoms. Is it clear now? This is the structure of silicon dioxide. This is the only difference, because obviously it is made up of two types of atoms, two types of elements, unlike diamond. अगर आप लोगों को समझ में आ गया तो आगे बढ़ते हैं. आगे बढ़ें बच्चों. या if you have any question, if you don't have any question. Ariba, we just discussed that that how each oxygen atom is bonding with two silicon atoms, and one silicon atom is bonding with other four oxygen atoms, because we read that the geometry of silicon dioxide is this. It was the question that described the structure of silicon dioxide. Were you present at that time? Okay. So I hope it is clear. I am moving ahead. Oh, Zainab has left the meeting. I think you guys are suffering with bad connectivity. Next topic is metallic bonding. So it can be taught with the help of this diagram only. It is actually the structure of metallic bonding. Metallic bonding is a bonding between the positive ions and the sea of delocalized electrons. Yes, I use the word sea because there are number of electrons which act as a glue between uh, with this positive ions, these positive ions. So just imagine this is a piece of metal having positive ions and lots of delocalized electrons. I told you that I will tell you the meaning of the delocalized electron. Actually, the actual meaning of delocalized electron is that this electron does not belong to any particular atom, particular ion. समझ रहे हैं आप मेरी बात? यानी कि इसमें जितने भी एटम्स मौजूद हैं उनमें से किसी एक से बिलोंग नहीं करता वो. तो वो मूव होते रहते हैं एक इलेक्ट्रॉन से दूसरे, एक आयन के पास से दूसरे आयन के पास, और ये इतनी ज़्यादा क्वांटिटी में होते हैं. दैट्स व्हाई वी यूज द वर्ड सी ऑफ इलेक्ट्रॉन. ये एज अ ग्लू काम करते हैं. ऑब्वियसली इलेक्ट्रॉन कैरी नेगेटिव चार्ज एंड आयन्स कैरी पॉजिटिव चार्ज, तो एक इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन डेवलप हो जाती है किसके दरमियान? इन दोनों इस स्पीशीज के चार्ज पार्टिकल्स के दरमियान. ऑब्वियसली यहाँ पे मैं इनको चार्ज कहूँगा. One thing to remember that we studied in ionic bond. Ionic bond is the electrostatic force of attraction between the two opposite ions. उसमें ions थे. That is why we use the word electrostatic, क्योंकि उन पे opposite charges थे. But we didn't use the word electrostatic for covalent bond. Remember, तो उसमें हमने electrostatic force of attraction नहीं कहनी, क्योंकि उसमें डोनेशन ऑफ लूजिंग और गेनिंग ऑफ इलेक्ट्रॉन नहीं होती थी, वहाँ शेयरिंग होती थी, तो वो चार्ज अपेयर नहीं होता. ऑल्दो यू विल स्टडी कि पार्शियल पॉजिटिव और पार्शियल नेगेटिव हो जाता है चार्ज, बट परमानेंट पॉजिटिव और नेगेटिव चार्ज वहाँ जनरेट नहीं होता. ठीक है बच्चों, तो पढ़ लेते हैं इसको कि metallic bonding is the strong electrostatic attraction between positive metal ions and the sea of delocalized electrons. What are delocalized electrons? Are electrons which are not associated with any particular atom. वर्क एग्जाम्पल में देख लिया आपने. They might ask you to label, they might ask you to draw the whole diagram. वो दोनों चीज़ें आपसे पूछी जा सकती हैं एग्जाम. What is the key skill? You need to be able to develop methods of learning of meaning the keyword, like okay, electrostatic or lattice. We know three-dimensional regularly arranged pattern is known as lattice, and the electrostatic means between two charge species. What common error we can commit? It is a common error to suggest that a metallic structure is the attractive forces between the ions instead of between the ions and the delocalized electron. Yes, I mentioned earlier that we have to be very careful because in metallic bonding there is an attraction between the positively charged ions and the delocalized electrons. But in ionic bond, it was between the two oppositely charged ions. Both were ions. But here, in the case of metallic bonding, the negatively charged particle electron is being attracted with the positively charged ion. Is it clear, बच्चों? Any question? All right. I have actually shared this book with you. You can copy it later as well, but no problem. You can copy it right now. Okay. Zainab, did you miss anything? Recordings will be shared. All right. So let me check what is left here. Yep. Metals conduct electricity because the delocalized electrons are able to move through the metallic lattice. Actually, the flow of electron is known as electricity. And there is sea of electron. तो भाई क्यों ना वो electricity conduct करेंगे? They are the best conductor. Metals are malleable. It means can be hammered into any shape. Metals are ductile. It means can be drawn into wire. Why metals have this property? Because the layers of metals atoms are able to slide when force is applied. For example, अगर हमारी गाड़ी पे कोई हिट करता है तो डेंट पड़ जाता है, बट ऐसा नहीं होता कि हल्के से लगने से वो शीट फट जाए. ठीक है, कोई भी मेटल ऑब्जेक्ट पे क्या होता है, उसकी शेप चेंज हो जाती है. तो ऐसा क्यों होता है? क्योंकि उसमें जो एटम्स होते हैं वो एक दूसरे के ऊपर से स्लाइड हो जाते हैं जब उनको फोर्स अप्लाई की जाती है. ये होता है. एग्जाम टिप यहाँ पे दी गई है कि व्हेन राइटिंग अबाउट द इलेक्ट्रिकल कंडक्टिविटी इन मेटल्स द आंसर it has free electrons is too vague to gain a mark. So the more accurate answer is there are mobile electrons, or you can say you can write delocalized electrons moving between the ions. Okay, it has free electrons. So what? Why they are malleable? Because the layers can slide when the force is applied, and strong metallic bond reform. वो bond तो नहीं उनका टूटता, लेकिन वो reform हो जाता है new position पे. Is it clear, बच्चों? If it is clear, so kindly attempt these two questions, 7A and 7B.